Hello everyone, and welcome back to the Fluctus channel. Pilots are often considered the heroes of the air because they are frequently tasked with flying dangerous missions and sorties. However, those same pilots will tell you that they wouldn't be able to do what they do if it weren't for the dedicated and highly trained men and women who inspect and repair their aircraft. In the United States Air Force, maintenance is of the utmost importance. Not only does it ensure operational efficiency and mission readiness, but it helps protect the two most important assets of any Air Force: the planes and the pilots. Contrary to popular belief, the most crucial point of concentration when maintaining a military aircraft is not the weapon system, but the safety equipment. These men from the 573rd Commodities Maintenance Squadron at Robins Air Force Base are working on the emergency slide of a KC-46 Pegasus. The Pegasus is a mid-air refueling plane and military transport, first introduced in 2019. Though it can operate with a crew of 3, it also has seating for up to 114 people. For this reason, the emergency door slides are extremely valuable pieces of equipment. The maintainers start by unraveling the slide itself and performing a mock inflation. Once the slide is fully inflated, they can inspect it for potential leaks or faulty equipment. This is made even more critical by the fact that these slides are designed to function as rafts in the event of a water landing. In such a scenario, a leaky raft would prove disastrous. Maintenance squadrons like these use various techniques and technology to identify potential defects and weaknesses in aircraft systems before they become problematic. One of these methods is known as non-destructive inspection. One way this is accomplished is by dipping various parts in a special dye. The part can then be placed into a developer, which will help pick up defects and cracks in the part. Other techniques involve magnetic particle inspections, which can also identify microscopic damage that would otherwise be invisible to the naked eye. If such a defect is detected, it could result in a single aircraft or even an entire fleet being grounded until the problem is properly addressed. Typically, the propulsion systems on an aircraft are very complex. On top of this, the various parts of each engine are under heavy wear and tear during regular operation. For this reason, engine components undergo frequent cleanings and inspections by well-trained technicians using a range of extensive equipment. Those defects that cannot be seen with the naked eye must be more closely investigated using laser measuring tools and other devices that can examine the parts at a closer level. Non-destructive inspection is a crucial process in the aerospace industry. Still, it takes on a whole new level of importance when the technicians deal with planes of a certain age. The Boeing B-52 Stratofortress is the oldest bomber still flying missions for the United States military. The first of these planes was introduced back in 1955, and a total of 744 aircraft were made between that year and 1962. On top of this, the Air Force plans to keep the B-52 flying for a full 20 more years. This NDI team is using a series of equipment in an attempt to find cracks and defects in B-52 components. After spraying the parts down with magnetic material, they are able to magnetize the part itself and inspect it using a blacklight. This reveals a large crack that would otherwise not have been visible. If this damaged part were to be placed back into the aircraft, it could result in a catastrophic failure even days, weeks, or months down the line. While the components are being inspected, a structural maintenance team is working to fix all of the physical damage different B-52 components suffer during their service life. These men and women are often tasked with hand-forming or refabricating structural parts to reduce wear. These structural sections not only protect the more sensitive components, but contribute to the aerodynamics and, therefore, fuel efficiency of the plane. Old or new, one of the most important aspects of keeping any aircraft flying is what's known as phase maintenance. Phase maintenance involves systematic inspections, servicing, and repair activities performed at predetermined intervals throughout the aircraft's service life. These intervals can be based on flight hours, flight cycles, or calendar time. Either way, the goal is to prevent wear and tear from accumulating to a point where it could compromise safety and mission capabilities. During phase maintenance, the B-52 undergoes a thorough examination, including structural inspections, avionics checks, engine inspections, and other systems evaluations. These inspections aim to identify and address any signs of wear, damage, or malfunction. If necessary, weak or worn components will be replaced or repaired. One of the most often overlooked aspects of maintaining an aircraft is regular washing. Though military aircraft indeed have far more critical threats to consider than dirt, failing to keep the planes and their components clean can actually lead to significant and sometimes tragic system failures. During any standard operation, planes and their parts are often exposed to things like salt water, sand, dust, and pollution. Accumulated grime and contaminants on the aircraft's surface can trap moisture, leading to corrosion of the aircraft's structure and components. Regular washing helps remove these contaminants and reduces the risk of corrosion, which can compromise the aircraft's structural integrity, aerodynamics, and even its ability to absorb radar. Washing large aircraft like the KC-135 and C-130 can take hours due to the amount of detail that goes into the process. Once the initial layer of grease is removed, washing crews will use heavy-duty soap and scrub every available inch of the jet's interior and exterior. With its 159-foot long fuselage and 185-foot wingspan, washing a B-52 is no simple process. These aircraft are typically washed every 120 days, but will undergo a deep cleaning every time that part of the phase maintenance comes around. During phase washes, all of the B-52's panels and compartments are removed to ensure the cleaners can access every part of the craft. Again, the main purpose here is to prevent corrosion, which, over time, can drastically impact the structural integrity of the metal. And because the soap used in the process is so powerful, cleaners must wear special suits and protective gear throughout. In recent years, the U.S. Air Force has been experimenting with special robotic aircraft cleaning systems. Thanks to their unique design, these systems can wash aircraft in a fraction of the time that it might take a human team. And while saving on manpower is a huge benefit, the robots aren't able to perform the visual inspection that goes along with the washing process. Of course, corrosion prevention is not just a concern for military planes. Though B-52s and F-16s may operate in harsher and more varied environments, passenger aircraft are also subject to extreme weather, pollution, and other corrosion-causing elements. For this reason, each airline and aircraft manufacturer has specified maintenance schedules for their products. In many cases, third-party contracting companies specializing in washing things like jet engines may be contacted to come out and perform the service. Companies like Juniper Aircraft Service Equipment in Liverpool, United Kingdom, use a range of equipment, including two 25-gallon wash rigs and Kyoto containment mats. This allows them to wash the engine while simultaneously collecting all of the water used in the process. This approach results in a clean engine, but ensures those toxic chemicals don't leach into the environment. Though they are effective, traditional engine washings can take hours to accomplish. For this reason, companies have developed new approaches to the process. SiClean is a unique engine wash system that can be carried out at the gate in less than an hour. It involves using only pressurized water heated up to 158 degrees Fahrenheit and sprayed directly into the engine intake. As with other processes, a specialized mat is placed around the engine to capture all the water and prevent contamination. Because of this single innovation, commercial planes can improve their fuel efficiency and increase safety without having to take the planes out of their regular flight cycles.